Hi everyone, I am Prachi Agarwal. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week, we'll post CodeChef problem explanations, conceptual videos on various programming paradigms, and also conduct live problem-solving sessions. But before we actually get started, here's a reminder to hit the subscribe button if you haven't yet already. Great! Now that you have subscribed, let's get started. Today we'll be solving the problem space arrays, which is an easy level problem, and it belongs to the March Long challenge. Now let us go to the problem statement. So in this problem, we are going to play a game which is known as space arrays, and it consists of two players. Now how are we going to play this game? So we'll be given a sequence A1, A2 up to AN. So there will be n elements that will be there in the sequence, and from this sequence we can pick up any one particular element and increment it by 1, and this can be done alternately by each of the two players. Now let us take n equals to 5, so that means there are 5 elements present in the sequence. Let us take any sequence randomly. I have taken it to be A1 as 3, A2 is 1, A3 is 2, A4 is 1 and A5 is 4. Now, each player one by one can pick up any element from this sequence and increment it by 1. But till when will they keep on doing so? So for that we have a condition here that every time AI should be equals to Pi, less than equals to Pi. This condition should be maintained. Now what is this Pi? So here you can see that P1, P2 up to Pn is given as a permutation of integers ranging from 1 to n. So that means if n is equals to 5, then this permutation will be 1, 2, 3, 4 and 5. This is what it will be there. And one more thing that is given to us in the constraint section, that if in the sequence, suppose A1, A2, An can be defined as Ai, where I is equals to 1, 2 up to n. Then in that case, what will be the range of values which the sequence can have? So Ai will be greater than equal to 1 and less than equal to n. These are the only range of values that our sequence can have. And also in the permutation, you can see that it is given as 1, 2, 3, 4 and 5. So that means the best way possible to check that AI should be less than equals to Pi, and all of these like if n is equals to 5, then all of these 5 values are present in our sequence, or the value should be lesser than this, but it cannot exceed these values. So the best way to determine that is that we fix our sequence to like A1 should be equal to 1, A2 should be equal to 2, A3 should be equal to 3, A4 should be equal to 4 and A5 should be equal to 5. If we fix these values, then we will always be able to ensure that our sequence is not violating this condition. Now, initially, it is not necessary that our sequence will be given as same as a permutation that we need to maintain, because we are playing a game, and in playing this game, we are choosing each time any particular element from our sequence and incrementing it by 1, right? So our sequence here, as you can see, that we have 2 times 1, then 2, 3 and 4, and we do not have a 5 at all. So that means, what are we doing? That initially we have a certain sequence and we want that this sequence should be turned into this permutation sequence, and in order to do that, we are choosing one element each and incrementing it by 1. Now, as you can see here, that A1 can only be 1. It cannot have any other values. So A1 can only have value as 1. Now what about A2? Here in the permutation, you can see that A2 is equals to 2, right? It can have the value as 2, but it can also have value as 1. Because it is given AI is less than equals to Pi. So that means A2 can be less than equals to P2 and P2 is 2 here. So A2 can be less than equals to 2. So hence A2 is equals to 1 or 2. These are the possible values that A2 can have. Similarly, A3 can have values as 1, 2 and 3. So these are the and similarly an can have values from 1, 2, 3 up to n. So these are the valid values that each of the elements in the sequence can have. But as you can see in our initial sequence here, that A1 is 3, which is not possible, right? It is violating this condition in an instant, and we can say that this game cannot be played further. But is that true? Because you can very well see that in this sequence, we have 1 here, we have 1 here. So why not replace this 3 by this 1? So what we can do that in order to place the correct values at the correct positions, we can sort this array. What will be the benefit of sorting? Like here in this permutation, we have this very one basic factor that it is arranged in an ascending order. So similarly, we want that our initial sequence should also follow that. It should also be in ascending order. Only then we will be able to match it with our permutation sequence. Now that I have sorted it, you can easily see the difference of each of the elements that are there in order to reach our desired permutation, that was 1, 2, 3, 4 and 5. And this difference, that means here it should be 2, but it is 1. So the difference is 2 minus 1 equals to 1. So what this difference signifies? This difference signifies that these are the number of moves that we can make, that many turns that we can play the game. That means for the second element, we can say that we can increment it once. And that's it. If we try to increment it any further, then it will violate this condition of AI less than equals to Pi. Similarly, you can see here in the third element also, we can increment it just once. Otherwise, if we try to increment it any further, then again this condition will be not satisfied. Then again this condition will become false and we cannot play any further. So this is giving us the ability to decide that how many number of turns this game can be played. So let us count. We will take it into a variable known as count, and we will count the number of times that this game can be played. So for the first one, here you can see that it is already 1. So 1 minus 1 is equals to 0. Then in the second element, you can see 2 minus 1 is equals to 1. Then for the third one, you can see 3 minus 2 is equals to again 1. And what are we subtracting the element from? So we are subtracting it from the permutation sequence, the AI equivalent of Pi. We are subtracting it from that, and that is essentially the index number. So we will take the index number, that is 3 or that is 4 here, and subtract it with its corresponding element. So now let us go to the fourth one. So 4 minus 3 is equals to 1. And again 5 minus 4 is equals to 1. So in total we have 4 moves that we can make in order to play this game. So that means that we can play this game 4 number of times, and at the end of 4 moves, who's going to win the game, the first player or the second player? How do we decide that? So it was already given in the problem statement that if the current player is playing the game, and in order of playing the game, the person violates this condition, then there and then the current player will lose the game, right? So there are 4 moves that are possible without violating this condition. So let us see. The first player will play, then the second player will play, then again the first player will play, and the second player will play. So until this point, this condition has not been violated. So these are the 4 moves that have been made. Now the 5th move that will be made will be by the first player. and this first player is violating the condition. That means this first player will lose the game. So here, if there are 4 moves, in that case, second player will win. So what can we decide after seeing this? That if the number of turns or the number of moves in total that we can play in this game are even, then in that case, the second player will win. And if the number of moves are odd, then in that case, the first player will win. And that's it. This is all we need in this problem in order to determine that which player will win the game. But there is one more thing that you will need to keep in mind. What if initially only the order is not up to the mark, the order is not what we need, that means it is not fitting this permutation order that we need finally. So let us see an example for that. This is the sorted array that we are going to check that how many number of moves are possible. So for the first one, you can easily see that there are no moves possible, that is it will be 0. Now for the second one, 2 minus 3 equals to minus 1. What is this? There are no moves possible for this one, right? But it is also violating our condition that AI should be less than equals to PI. So initially only, without even determining that how many moves are possible, we can easily see that this particular element is violating our condition AI less than equals to PI. It means that there are no number of moves possible. The player will not even start the game and the condition is already violated. So what do we do in that case? In that case, we can say that this was the first player's turn, right? And when the first player will play, then already this condition has been violated. So in that case, the current player will lose, and the current player is the first player. So in this case also, the second player will win the game. So that means we will have to keep in mind that if initially the condition is violated, that means it is greater than its original expected permutation value that we wanted, then in that case also the second player will win. So guys, I hope that you must have understood this problem and now you will be able to code it on your own. So please try it, and if you're not able to solve it, then we will code this in Python and you can check it out. But this was just one problem that we were able to solve, and you might have been able to solve, or you might not have been able to solve it. So why not go to the Unacademy app and register yourself there by using my coupon code known as Prachi16. So you can use this coupon code to register yourself and have access to all the free content that CodeChef is providing on the Unacademy app. And there you will find all the topics related with competitive programming, and that too for free. All the live classes are there for free. There are basic topics, advanced topics that are there to cover. You'll find a repository of all the competitive programming stuff related there, taught by the top coding experts. So please do give it a try, and I hope that you'll be able to enhance your coding to a great extent. So guys, now we will code this problem in Python. So first we have the number of test cases as the input. Then we have the first few lines as the input. N is for the number of elements that will be there in the sequence, and A is the sequence itself. Then we have taken S equals to 0. S means this is going to count the number of moves that we will have for which we can play the game. Then we are sorting our sequence. So as I told you that sorting the sequence will help us place the correct element in the correct order in the sequence. So that is why we need to sort our sequence. After that, this is last I. So this is there to store that up to what point we have reached without violating the condition AI less than equals to PI. So we'll be going to each of the element of the sequence by running a loop, right? So we also need to find out that up to what point we can go into the loop without violating this condition AI less than equals to PI. So this is just basically to keep a check that initially only our condition should not be violated. So now we are running a loop for I in range up to n. So this loop is there for going to each element of the sequence. Then we will simply check that if a of I is less than equals to I plus 1. So that is what we need, right? This is the condition that we need in order to not violate this particular condition. So that is why we are checking this, and if it is true, that means we have not violated this, then we will add I plus 1 minus ai. So like we were doing when we were counting the number of moves, right? So this is what we were doing. Here we are doing I plus 1 because we already know that indexing starts from 0 and in our sequence starts from 1. So that is why we need I plus 1 here. And then we will store I in last I because we need to keep a check here. Now in the else part, we are directly doing break. Why? Because if this condition is violated, that is ai is less than equals to I plus 1 is violated, it means a of I will be greater than I plus 1. If this is so, then that means that if whatever we do, we cannot move our game further. Means initially only our condition is violated and we cannot play this game at all. So we do not need to do all these, count these moves, and we will directly come out of this loop. Now here you will see the significance of this last I. So here you can check that if last I is less than n minus 1, it means it has not reached to the end of the sequence, and in between only we found that this particular condition was violated. So in that case, or if the number of moves are even, then in that case the second person will win. So we will keep the answer as second. Otherwise the answer will be as first, and then directly we will print the answer. So that's it guys, this was our problem. This was the code to the problem. So I hope that you have understood the code. If you have any doubts or feedbacks, then please feel free to post it in the comment section below. And also there are some other methods to solve this problem, so you can also discuss that in the comment section. And also I would like to discuss the time complexity. So here for sorting, we have the time complexity as order of n log n, and then we are just running a loop for n values of the sequence, so it will be order of n. So this will be the time complexity of the method that I have used to solve this problem. So there are other methods as well, so please think of it and do post it in the comment section. And you can also stay updated by subscribing to our channel, and then you will get all the updates regarding the latest videos that will be posted on our channel. So please don't forget to hit the bell icon and subscribe to our channel. You can also stay updated via our Telegram channel. The link is given in the description box below. So guys, please don't forget to subscribe to our channel and like the video, and I'll see you in the next one.